Hey, hi and welcome back. So in previous video, I gave you the brief introduction to the 7 segment LED display, and in this video, we are going to see the 7 segment display driver IC. Alright, so I hope that you will enjoy this video. Now let's start with this video. So now let me tell you what you're going to learn in this video. So the first point is introduction to CD4511B. So CD4511B, this is basically the part number of IC that we are using in our design. Okay. And CD4511B is basically a 7 segment display driver IC. And in this video, we are going to discuss every single thing regarding this IC. So that was the first point, introduction to CD4511B. Then the next point is pin configuration. So as I told you, whenever we deal with any kind of electronics component, it's very important to understand the pin configuration of that particular component. So again, for this particular IC, we will see the pin configuration and we will try to understand the significance of each and every pin which is there on this particular IC. Okay. Then the next point is functional diagram. So whenever we deal with any kind of IC, if you have to understand the internals of that particular IC, then you should always check the functional diagram. So again, we will see the functional diagram of this particular IC in order to understand the different blocks which are present in this IC. Then the next point is function table. So with this table, we will try to understand the working of this particular IC. Okay. So we will see how exactly this IC behaves for different, conditions. So that's how basically we are going to cover this video, and this particular IC is actually very simple and I hope that you will definitely enjoy this video. So now let's start with this video. So this is how basically the 7 segment display driver IC look like, and as I told you, we are dealing with CD4511B and this is actually a BCD to 7 segment display driver IC. So there are actually, different types of 7 segment display driver IC available in market, but this particular IC is actually very popular and this is actually one of the oldest IC which is used, in order to drive this 7 segment display. And again, this particular IC you can procure easily from the local market. Okay, that's the reason I have choose this particular IC. But it's not like you should go with this IC only. As I told you, there are different ICs available in market, so you can also go with those ICs. Okay, so this is the CD4511B, which is BCD to 7 segment display driver IC, and you can see it's actually a 16 pin IC. There are total 8 pins on the left hand side, and then again there are total 8 pins on the right hand side. And always remember, the first pin which will be there on the left hand side of the notch, that pin is actually the first pin of any IC. Okay, it's not just in this case. So that's the CD4511B, and now let's try to understand the pin configuration of this IC. So the pin configuration of this IC is very simple. We will start from the VCC pin. You already know this is basically the pin to which we provide the power, and we can provide up to 6 volt to this particular pin. So in our case, we are actually going to, generate 5 volt with the help of 7805 power supply section. So we are going to provide 5 volt to this particular pin, which is pin number 16. And as always, this pin number 8 or this particular pin will be connected to the ground, which is the ground pin of this IC. Okay, so we are done with the 2 pins. Then now let's try to understand these all pins. So these all pins are actually the driver output. So there are actually drivers inside this IC, and these are actually the output of all those drivers. And we are going to connect these pins to the 7 segment display. So we saw that in 7 segment display, there was ABCD kind of pins. In the same way, on this particular IC, again, you can see there is A pin, then B, C, D, E, F and G. So all these pins will be connected to this 7 segment display. So that's all about these all pins. Then on the left hand side, you can see there are D0, D3, D1 and D2. So as I told you, this is basically a BCD to 7 segment display driver IC. You already know what exactly BCD is. BCD is actually representation of the decimal number. So you need to provide the BCD inputs to this particular IC to these pins. So there will be combination of 0000, then 0001. So likewise you have to provide that combination on the input side, and based on the combination that particular pin or that particular LED will get switched on the 7 segment display. For example, if you provided 0000 combination on D0 to D3 pins, then these 0 digit will be displayed on the 7 segment display. And likewise for rest of the BCD combinations, you are going to get the different digits will be displayed on the 7 segment display. So very simple, nothing complicated. These are just the BCD input pins of this IC. Okay. Now let's try to understand this pin, which is LT pin, and LT actually stands for lamp test. So lamp actually means the LEDs that we are going to connect, or the 7 segment display that we are going to connect on the on this side. They are actually considering, this IC is actually considering them as a lamp. So there are total 7 lamps, or there are total 8 lamps, including that dot point. But this particular IC is actually capable to drive only 7 lamps. So when you connect this particular pin to ground, so this is actually active low pin. Wherever you will see this bar above that particular pin name, it actually indicates that that particular pin is active low. So when you connect pin number 3 to ground, all the LEDs which will be there on the 7 segment display, all those LEDs will get switched on. The reason is all these pins are going to have logic 1 when you connect this LT pin to the ground. Okay, so LT, as I told you, it actually stands for lamp test. So you need to provide logic 1 or plus 5 volt to this particular pin. Then only all these pins will have logic 0, and as a result all the LEDs which are there on the 7 segment display will get switched off. So I hope that this particular pin is now clear to you. Then the next pin is blanking input. So you can see here I have written blanking input, which stands for BL. So again, this particular pin is active low, which means that if you connect this pin to the ground, then there is actually a decoder block inside this IC. So if you connect this particular pin to ground, then that decoder block will actually get disabled. So always you remember, you need to provide logic 1 to this particular pin, then only that decoder block will get switched on. Okay, so you will get that in a moment what exactly decoder block is. So at this moment you just remember that you need to connect, you need to provide logic 1 on this particular pin in order to enable the decoder block. Then the next pin is LE, which stands for latch enable. And this pin is actually, actually I have used, this diagram is from different IC, which is 74HC 4511. Okay, so this diagram is actually from this particular IC. I have taken the diagram from this IC because the CD4511, as I told you, CD4511B, this IC is actually very old. Okay, and if you check the datasheet of this IC, then you will find that the diagram is actually not properly shown in that particular datasheet. Okay, so as I told you, this IC was very old. So the datasheet which were printed in those days, they didn't have good quality. Okay, so you check the datasheet of this particular IC and you will get to know why I have taken this particular diagram. Okay, so if you check the datasheet of this IC, then you will find that this pin is actually not active low. So for this IC, this pin is not active low, but for this particular IC 74HC4511, this pin is active low. So as we are using this particular IC, so let's try to understand the functionality of this pin with respect to this IC. So LE as it stands for latch enable. So again, there is actually one more block inside this IC, which is latch enable. So when you connect this particular pin to ground, then the latch enable block will actually get enabled. And if you provide logic high to this particular pin, then that latch enable block will get disabled. So you need to connect this particular pin always to the ground in order to enable the latch enable block. So I hope that it's clear. So we have discussed every single thing regarding this IC. I hope that the pin configuration of this IC is now clear to you. So the pin configuration is actually very simple. Alright. So now let's go ahead and now let's try to understand the function block diagram of this IC. So this is how basically the functional block diagram of CD4511B look like. And as I told you again, in this case, I have actually taken this particular diagram from the same IC, which is 74HC4511. That's why the diagram is of good quality. And as I told you, this particular pin, which is latch enable, it will be active high. So you can see inside this IC, there are actually 3 different blocks. Latch block is there, then decoder block is there, and then driver block is there. So driver is actually responsible for generating the different logics, or it's actually responsible, for amplifying the current. So if you provide the output of decoder block directly to the LED lamps, then the intensity of those blocks, those LEDs will not be too much high. That's the reason IC manufacturer has included this driver block inside the IC. So the first block is latch block, and we need to provide the BCD inputs to this particular IC. So that BCD input, those BCD inputs will, first of all, it will go to the latch, and that's the reason we need to provide logic 0 to this particular pin, which is latch enable, so that this particular latch will get enabled, and these inputs that we have provided, they will proceed ahead. Okay, so if you provide 0 0 0 0 here, then that 0 0 will travel here only when this latch enable block is enabled. Then these all logics will travel towards this decoder block, and this decoder block is actually responsible for converting these all logics or this particular BCD combination to the combination which is actually required for 7-segment display. So based on the combination, this decoder block is actually going to generate, logic for the respective digit. So for this particular, combination, the 0 should be displayed on the 7-segment display, right? So this decoder block is going to generate the respective logic so that the 0 will be displayed on the 7-segment display. And then this driver block is actually going to amplify that logic, and then so we can provide that signal to the 7-segment display. Okay. So that's basically the decoder and driver block. And again, as I told you, this is basically the blanking input. So if you connect this particular pin, BL bar pin to the ground, then this decoder block will get disabled. So even if latch enable is enabled, the data will travel on the input lines of decoder. But as this decoder block is disabled, so you won't get any data on the output side. That's the reason we need to provide logic 1 to BL, okay? And this LE should be connected to the ground, or there should be logic 0 on this particular pin. So I hope that the functional block diagram of CD4511B is now clear to you. Now let's go ahead. So this is actually the functional table of CD4511B. And again, I have taken this particular table from the datasheet of same IC, which is 74HC4511. Okay, so here again you will find that this LE, it will be bar, so here it will be just LE. Okay, it will not be bar. So this is actually a kind of truth table. Okay, so if LT bar is low, it means what? All the LEDs will get switched on. So it doesn't matter what you provide on this LE pin or BL pin, all the LEDs are actually going to be they will get enabled. So you can see this pin number A, B, C, D, all the pins are going to have the logic high, and the digit 8 will be displayed on the 7-segment display. So likewise for different logics, for example, for this combination 0000, the digit that will be displayed on this 7-segment display, it's going to be 0, because the G LED, this particular LED will get switched off. Okay, so rest of the LEDs will get switched on. That's the reason you will be able to see 0 here. So if you provide this combination on the BCD inputs, then this logic will generate, and this LED B and LED C, these are the only LEDs which will actually get switched on. Okay, so you can see on B and C there is high, and for rest of the pins there is low. Okay, So that's how basically the functional diagram is, nothing complicated, very simple. So this functional diagram actually helps you, to write the code. For example, whichever digit you want to display on 7-segment display, you just have to check this particular combination. You have to write this combination in the program for the respective digit, and then that particular digit will get switched on. So that was all about the functional diagram, and that's what I wanted to tell about the CD4511BE IC. I hope that every single thing that we discussed regarding this IC is now clear to you, and if you still have any kind of doubt, then definitely you can reach to me and I will help you with that. Okay, so now I will see you in the next video, which is about understanding circuit of 7-segment display. Okay, so I will see you in the next video now.